Welcome to Quick Byte series. Today we will solve 3 questions based on capacitor. These questions I took from previous VSSC Technician B Electronics question paper. So let's move to the first question. A square pulse of 3 volt amplitude is applied to the RC circuit shown in the figure below. The capacitor is initially uncharged and the output voltage V out at time t equals 2 seconds is. We have to find the output voltage, and I see even this question I have made a mistake previously while solving the question paper. The output is taken across the 200 kilo ohm resistor. So what we have to find, what is the output V out. Now first let us find the RC time constant of the circuit. So value of the capacitor is 10 microfarad. And this is 200 kilo ohms. Now what is the RC time constant? That is tau. Tau is the time constant, which is equal to RC equals 200 kilo ohm, 200 multiplied by 10 to the power 3 for the kilo ohm, 10 microfarad, 10 to the power minus 6. So this 200 I can write it as 0.2 multiplied by 10 to the power 3, right? If you will get it back, we will get back 200. So 10 multiplied by 10 to the power 3. Same 10 to the power 3 is coming here. 10 to the power 3, again 10 into 10 to the power minus 6. Now this 10 to the power 3 and 10 to the power 3 gets added. So we'll get 10 to the power 6. And that 10 to the power 6 and 10 to the power minus 6 cancels out. So what is the time constant? 0.2 multiplied by 10, which is equal to 2 seconds. 2 seconds. So he is asking the V out at time t equal to 2 seconds. So first we have to find at 2 seconds what is the voltage of the capacitor if we apply 3 volt. He has given 3 volt 4 seconds. So this square wave pulse is going to act like a constant voltage for this one time constant. So all of us know what we know. We know capacitor charging, time versus charge across capacitor while charging. Okay. So the time taken for the capacitor to charge 63% of the max value is known as max value. It takes one time constant, that is 2 second capacitor will charge to 63% of the 3 volt. 3 volt is the voltage maximum this capacitor can get charged, because that is the source, 3 volt. Now we'll find after one time tau what is the voltage across this capacitor. At 2 seconds Vc equals, what is the Vc? How do you find? What is the source voltage? 3 volt multiplied by 0.63. 63% I am writing as 0.63. It comes to 1.89 volt. But this is not the answer. Why it's not the answer? He is not asking what is the voltage across the capacitor. He is asking what is the voltage across the resistor. That's what the V out he has shown. So Now we will find what is the V out. This circuit we can just write this is like a voltage divider, right? This capacitor we have here, a resistor we have here, resistor in series with the capacitor. This is 200 kilo ohm, and this is what is the capacitance value, 10 microfarad, and we are applying 3 volt here. Now we know at 2 seconds, that is at 1 tau, what is the voltage drop across the capacitor? 1.89. At the same time, what is the output voltage? That's what the question. That is the question. So this is our V out. V out. It's a series voltage divider with capacitor and the resistor. So we know total applied voltage is 3 volt, and the voltage drop across the capacitor is 1.89 volt. So what is the V out? V out equals 3 volt minus the drop across the capacitor, that is 1.89 volt. So it comes approximately 1.1 volt. So the answer is option C. Next question. 2 metal plates, each of 2 cross 3, 2 multiplied by 3 centimeter, are separated by 0.1 mm with air as dielectric. The value of capacitance will be. How do you find what is the basic equation, fundamental equation to find the area of capacitance of a capacitor if the area of the plates and the distance between them is known? It is C, capacitance equal to A epsilon naught epsilon R is the relative permeability. Permittivity, not permeability, that is in the case of magnetism. Epsilon R is the relative permittivity upon D. So this equation you should know. This is fundamental equation to find the capacitance. So once you know this, now we have to apply these values here. So see what he's saying, area he has given, 2 metal plates. So we have a metal plate like this. Two by 3. So what is area? If we multiply these two, 3 multiplied by 2, we will get 6 centimeter square is the area. So now, but all we have to put it in SI units, right? So what is the area? Area we have 6 centimeter square, but we have to convert it into meter square. Centimeter square, how do you convert into meter square? You have to multiply it by 10 to the power minus 4. Epsilon naught, permittivity of free space. He has given it as, it is a constant, it is 8.85 multiplied by 10 to the power minus 12. What is the permittivity of air or vacuum? It is 1 divided by, what is the distance? Distance he has given us 0.1 mm. So we have to convert it to meters. To convert it to meters, what do you do? Multiply by 10 to the power minus 3. Now we will simplify this. This 8.85 I will round it off to 9 because we are not having calculator in the exam. So 6 into 9 multiplied by 10 to the power minus 4, 10 to the power minus 12. Same base, so powers we can add it up. So when you add, we will get 10 to the power minus 16 upon this 0.1 we can multiply and divide by 10. So what happens? 0.1 0.1 we can multiply by 10 and divide by 10. If I multiply by 10, it will become 1. If I divide by 10, then what happens? It becomes 10 to the power minus 4. Alright, this is how I wrote this. This is 0.1 multiplied by 10 divided by 10. So multiply by 10, I'll get same, I will get back, right? 0.1 I will get back. So top I'll write it as 1. This 10 I will take to the numerator, so it will become minus 1. So I will add this minus 1 with the minus 3. So it becomes 1 multiplied by 10 to the power minus 4. Now let's simplify. So we can strike off this. So what we get? We will get 10 to the power minus 12. Right. Now 6 9s are 54 into 10 to the power minus 12. See, 10 to the power minus 12 means what? Picofarad. It is 54 picofarad. So we have to see any close range is there for the 54 picofarad in the answer. It is 53.1 picofarad is there. So the answer is 53.1 picofarad. This is the last. Today we have one more small question is there. 4 questions are there. The 4th question you can try yourself. So what is the total capacitance in the given circuit? How do you find? When capacitors are connected in parallel, it is easy to find the capacitance. You have to just add it up, right? Now, these 2 farad and 2 farad capacitors are in series. This is 2 farad, 2 farad. This let be A and B connected across A and B. What is the total capacitance? CT equals, it is like resistors are connected in parallel. C1, this let be C1, let me mark it as C1, C2. C1 multiplied by C2 upon C1 plus C2. This will give us the equivalent capacitance when capacitors are connected in series. But if the same value of capacitors are connected in series, how do you find out? Here we have 2 farad, 2 farad. Then CT equals C upon N. What is the C here? It is 2 farad. 2 farad upon N. What? How many number of capacitors? 2. So this answer equal to 1 farad. 1 farad. So these 2 capacitors we can replace by a 1 farad capacitor. 1 farad capacitor. Now it is very easy. Now we have 3 capacitors in parallel. Six farad. Again we have one more 6 farad. Then we have our equivalent 1 farad. 1 farad. And now what is CT? It's the across A and B. What is CT? Total, that is equal to C1 plus C2 plus C3 when capacitors are connected in parallel. So 1 farad plus 6 farad plus 6 farad. What is the answer? It comes to 13 farad. 13 farad is the answer. So answer is option B is the answer. This is the last question. Solve yourself. 3 numbers of 120 picofarad capacitor are connected in series. The effective capacitance is. So I hope these videos are useful to you for your exam preparation. If so, please share with your friends. Also don't forget to hit the like button.